Alright, we're midway through page 38. We're going to have a look at exponential equations here. So what is an exponential equation? An exponential equation are equations where the pronumeral or the letter appears as an exponent or an index. So the x will appear as the power. Okay, whatever you're trying to solve for will appear as the power. To solve exponential equations, there's two methods. We're only going to have a look at the first method here, and that is involving making the bases the same on both sides of the equation, and then you equate the exponents. The second method, which you'll learn later on in the course, uses something called logarithms. Alright, so each of these questions are going to be special in that you can always make the bases the same. So let's go. So this first one here, quickly you can realize that 27 can be written as 3 to the power of 3. So we've got 3 to the power of 1 minus x equals 3 to the power of 3. Therefore, 1 minus x must equal to 3. Minusing 1 from both sides, dividing by -1 or moving the negative across, you get x as -2. This one here, I've got an 8 and a 4. The common base will be 2. Okay, so 8 is 2 to the power of 3. And 4 is 2 squared. So that's 2 to the power of, and when you multiply this out, it'll be 3x minus 6 is equal to 2 to the power of 2. So therefore, we've got 3x minus 6 equals to 2. 3x equals to 8. X equals to 8 on 3. Okay, next one. Another one with a common base of 2, because 4 is 2 squared. Okay, now 1 on 8 is 1 on 2 cubed, and we can bring that up the top and make it 2 to the power of -3. So that's 2 to the power of -3 times x. Let's now expand carefully. So 2 to the power of that'll be 4x minus 2 is equal to 2 to the power of -3x. So therefore we've got 4x take away 2 equals -3x. Adding 3x to both sides. Plusing 2, dividing by 7. So we get x as 2 on 7. Okay. Next. Okay, this one I've got a product equaling 0, another product equaling 0. So therefore 3 to the x minus 1 equals to 0, or the second 2 to the 2x minus 1 on 16 equals to 0. Okay, let's bring this across. Now, I can make 1 with 3 to the power of what? Well, it must be 0. 3 to the power, any number to the power of 0 is 1. So therefore, this has a solution of x equals 0. This one, 2 to the 2x equals to 1 on 16. 16 is 2 to the power of 4. Bring it up the top, it comes 2 to the negative power of 4. So therefore, 2x equals to -4, x equals to -2. So we've got 2 potential solutions there. Okay, E. 64 and 32, they're both 2 raised to different powers. So 64 is 2 raised to the power of 6, and 32 is 2 raised to the power of 5, but it's a square root, so put on 2 there. So therefore, equating, we've got 6x equals to 5 on 2, so therefore x is going to be 5 on 12. Okay, last one. Okay. We've got 2 terms here that involve a power of x. That's not very nice. You only want 1 term involving a power of x. So we can manipulate. The first term is 2 times 2 to the x. And then we can factor out the 2 to the x. It'll be 2 plus, and then that'll be 1 lot of 2 to the x. And that's just going to be a 3. dividing through by 3 we get 4. Well, that's good because 12 you can write as 2 to the power. But that's nice and easy now, because 4 is 2 squared, so therefore x is 2. Okay, a little aside at the bottom, it's not if it is not possible to make a common base, you'll need to use logarithms to solve those exponential equations, but at the moment we're focusing on solving exponentials by making a common base. We'll look at using logarithms when there's uncommon bases later on in the course. Alright, time to do 8.3. It's a pretty short exercise. Good luck with it.